Okay, today we want to deal with the laws of indices. So there are 7 laws of indices that we must understand, and these laws, they are very, very important. And for us to really understand, I think we have discussed what a base is. That is when we look at something like this, like if this is b, for instance, b x raised to power a. We told us this one is called power. This is power or index. We call it index. We call it power or we call it index. So index, as we know it as power, the singular is index, but when it is plural, we call it indices. So that is why we are talking about the laws of powers, which is also the laws of indices. So index is the singular, but plural is the is indices. This is coefficient and this is the base. So what this law is now telling us is telling us how to, when we multiply them, divide them, then all these laws, they must always come. We must always apply them whenever we see them in mathematical expression. So the first one of this law is x raised to power a times x raised to power b. So whenever we have a base having a power and another base having another power or the same power or wherever the power is, this a could represent any number and this b could represent any number. So when they multiply each other, then we add their powers. So this is the first law of indices. When the bases are multiplying each other, we do what? We add their powers. So that is one of the laws of indices. Then the second law of indices is that when x is raised to power a divided by x raised to power b, then we subtract their powers. So that is x raised to power a minus b. So x raised to power a divided by x raised to power b is going to be x raised to power a minus b. So that is the second law of indices. Now the third law says x raised to power 0 is equal to 1, which means whenever the base is raised to the power of 0, it is equal to 1. This x could be anything. So it could be 2 raised to power 0, of course it's 1. It could be 1000 raised to power 0, is of course equals to 1. So whatever is raised to the power of 0, the value is 1, no matter what. Now this is the first law of indices. It says x raised to power minus a. It's going to be 1 all over x raised to power a. So what that implies is that this minus will leave this place and become 1 all over. Then whatever is now left, this x and the a, they will not be on the denominator. So this is the fourth law of indices. Now the fifth law of indices, that one says x raised to power a into brackets b. That is, whenever we have one power is in the brackets, then the second power is outside the brackets, then the two powers will multiply each other. So that is what this one is telling us, is that when this one is within a bracket, this one is outside the brackets, so they are as good as multiplying each other. So it becomes x raised to power ab. So this is the fifth law of indices. And the sixth law of indices states that x raised to power 1 all over a is going to be the 8th root, that is a, its roots of x. So 8th root of x, so if this one is 2, it's going to be the square root of x, that is 2. If it is 3, we call it the cube root of x. If it is 4, we call it the 4th root of x. If it is 5, we call it the 5th root of x. If it is 6, we call it the 6th root of x. So x raised to power 1 over a is going to be the 8th root of x. Now the 7th law of indices states that x raised to the power a over b. So whenever we have a fractional power, this is what happens when we have a fractional power. The one at the denominator will now be the bit root, while the one at the numerator will be of x raised to the power a. So this is like when we have this one here, that is, this is like 1 all over b here, like this one is 1 over a, which is 8 roots. 1 over b here is going to be the bit roots. Then this a is now coming out, so which is what we have, that like, you know, like this one, like when we have this x raised to power a, then raised to power 1 all over b, we apply the fifth rule. The fifth rule, which is x raised to power a and b, it becomes x raised to power ab. So what this one is telling us is this one and this one, they are multiplying like this. You know, if we multiply this and this, will come back to this. So if we have applied fifth rule here, now if we now apply the sixth rule, which is having this x raised to power 1 over a, which is of course applying this, it becomes the bit root of x raised to power a. See, so this could also be written like this: the bit root of x, everything raised to power a. That is, you put everything in brackets. The bracket now, this now comes outside, and the power of this one is 1. It is still the same thing, because if this one multiplies this, of course we still get the same answer. So these are the 7 laws of indices. So the laws are: when they are multiplying, you add the powers; when they are dividing, you subtract the power; when it's raised to power 0, it's 1; when it is x raised to power minus a, it's gonna be 1 all over x raised to power a. Then x raised to power ab is gonna be a into bracket b, it's gonna be x raised to power ab. Then x raised to power 1 over a is gonna be the 8th root of x raised to power a all over b. It's gonna be the bit root of x raised to power a. So this are the 7 laws of indices. So at this point, we will now look at the different examples of these laws, so where we see them in application. Okay, now looking at this example, we see that this is an example of the first law of indices. So when we are applying the law of indices, we apply it to the bases. You know, these ones, they are the coefficients, and the law does not apply, does not reflect on the coefficients. So the coefficients will undergo their normal multiplication, but the basis will be applied with the first law of indices. So we apply the first law of indices to the basis, and the basis is x raised to power 3 and x raised to power 4. So the first thing we will do is to multiply 2 and 3, and 2 and 3, multiplication of 2 and 3 is going to be 6, and x will now become 3 plus 4. So the final answer is going to be 6x raised to power 7. So this is the final answer. Okay, so looking at this example, we see that these are the bases. We need to multiply the coefficients. The coefficients are 5 and 2. 5 times 2 is going to be 10, and x will now be raised to power 3 plus 3 all over 2. So we need to add the powers, and when we add the power, it's going to be 10x raised to power, that is, if we want to add a fraction and a whole number, we say 2 times 3, 6, plus 3, 9 all over 2. 9 all over 2. So this gives us the answer, and we can stop it here, or if we want to apply the 7th law of indices here, of course this is going to be 10, then square root, that is 2 will be here. But in mathematics, when it is square roots, we don't usually write it down. We don't usually write it here, which means normally when you see square root in mathematics like this, it shows that what is here is 2. that 2 is not normally written. It is only when it is different from 2 that we need to write it there. But if it is 2, we don't usually write it. So it's going to be x raised to power 9 here. So this is going to be the final answer. So normally when you see this in the textbooks, you will see that it will be written like this: x raised to power 9. So this is the final answer. And also you should note that the coefficient is different from the base. So when you are applying the law to this, you apply the law only to the base, not to the coefficient, because the coefficient is different from the base. You see, when we are applying this law here, we did not put this 10 inside the radical sign. We call this radical sign. We don't put the 10 inside the radical sign, because it does not have the same power as this. So they are not this is a coefficient and this is a base carrying this power. So the law is going to be applied to the base. So this is how this one is going to be written, because a very good mistake that students usually make is they will write this one as 10 raised to power x raised to power 9 all over 2, and then they will now say it is equal to 10x raised to power 9, which is wrong. So it is wrong. So the right thing to do is to separate the coefficient from the base. So which is what we have done. Okay, so let's see another example. Okay, looking at this example, we'll see that there are two bases in this multiplication. We see that there is x, which is raised to power 4 here. X is also raised to power 1 here. Then this one and this one, they are also bases, but these are coefficients. 3 is a coefficient, 2 is a coefficient, and 3 is a coefficient. So the ones that are coefficients, we simply multiply them out, because the law does not affect them. It is the ones with the powers that we're now going to deal with, that we're going to affect the law on. So it's going to be 3 times 2, 6, 6 times 3, 18. So you have 18 here. Then x raised to power 4. Then x is raised to power 1 here. If nothing is written here, we know it is 1. So it's going to be plus 1. Since everything here is multiplying, so we are going to add the powers. Here we don't have x here, but we have x here. So as long as everything is multiplying, we know the multiplication cuts across. So it's going to be 4 plus 1. So that's for that one. Then for this one, it's going to be y raised to power 5 plus 2. So we apply the first law of indices to each of the bases in the expression. So it's going to be 18x raised to power 5 and y raised to power 7. So which is the final answer. Okay, so when given this question and we are asked to simplify this question, so what we see from here is that 3 raised to power 3 raised to power n. So 3 raised to power n minus 1 here is just to power n minus 1 here. So we can apply first law and second law of indices to this. So for the first law of indices, just as we know that 3 raised to power n minus 1, we can reverse that particular law and write it as 3 raised to power 3 multiplied by 3 raised to power n minus 27 times 3 raised to power 3, then times 3 raised to power minus 1. That is, according to first law, when they are adding, we do what? We multiply them. That is, when they are multiplying, we add the powers. And this is going to be, sorry, this is supposed to be n. It's supposed to be n minus 1. Just as what we have here, n minus 1, right? And this 27 can be written as 3 raised to power 3. 3 raised to power 3. This times 3, 9, 9 times 3, 27, right? So, and this is going to be divided by 3 raised to power n minus 3 raised to power n times 3 raised to power minus 1. So if you observe this clearly, at the numerator there are 2 terms, at the denominator there are 2 terms, and something is common. that we can easily see. We see that here 3 is what's it called, 3n is common. This is also common, right? So since this is common and this is common, we can bring out what is common. And even here 3 raised to the power 3 is common, 3 raised to the power 2 is common, but 3 raised to the power n is also common here. So at that point, what do? We bring out what is common. 3 raised to the power 3 times 3 raised to the power n is common. We open the bracket. What are we going to be left with? So when we say this divided by everything here, that is this one, we're going to be left with 1 minus, now 3 raised to the power 3 and 3 raised to the power n here, we are going to be left with 3 raised to the power minus 1 here. So that's for the numerator. And for the denominator, 3 raised to the power n is common. So it's going to be 3 raised to the power n. We open the bracket, that will be 1 minus, that is when we say 3 over n. 3 raised to the power n divided by 3 raised to the power n is going to be 1. And 3 raised to the power n divided by these two, this is cut this, we will be left with 3 raised to the power minus 1. Right? So this is going to be the final answer. So if we observe this clearly, we see that this is going to cut this, and this also they're also equal. So it's going to be cutting this as well. So the final answer is going to be 3 raised to the power 3. So this is going to be 27. 3 times 3 times 3, 27. So this is the final answer. You can see it's simplification. So factorization, then simplification. So this is how we simplify this expression when we see it in our exams, right? So we'll leave it here today. So we're going to continue to solve some examples on in our next video. Please subscribe, like, comments, and subscribe to our YouTube channel. Yeah, we want to see your comments and what you want to tell us about what we have been doing so far. Thank you.